Next combination circuit is a multiplexer. We'll take the example of a particular multiplexer and explain what actually a multiplexer is. So we are considering here a 4 by 1 multiplexer. Multiplexer is also called as for EC usage a mux. So in a 4 by 1 mux you have 4 inputs, 3 and 4. So I will notate it as say I0, I1, I2 and I3. 1, 2, 3, 4. So 4 inputs. These are my inputs and 1 output. Let me notate it as Y. Y is my output. So this is called a 4 by 1 mux or 4:1 mux. Both are the same. Okay. So in a multiplexer, you have many inputs but only a single output. Always. Only one output but there will be many inputs. So how do we decide as to how many inputs should be there? And what does a multiplexer do? So what a mux does is that you have inputs, many inputs, and one of these inputs is selected by the multiplexer, and whatever is there in that particular input is transferred to the output. So in order to select one of the inputs, you have select inputs. Okay, you have select inputs. These are called as select inputs. So in a mux you have inputs, select inputs and output. Now what is the relation between all these? Output you have only one. For any mux there is only one output. So what's the relation between select inputs and inputs? If there are n select inputs, then you have 2 raised to n inputs. That is the relation between the select inputs and the inputs. If you have n select inputs, you can have 2 raised to n inputs, or if you need 2 raised to n inputs, then you should have n select inputs. So in a 4 by 1 mux, 4 is the number of inputs, that is 2 raised to n. So 2 raised to n is equal to 4. So 2 raised to n equal to 4 means 2 raised to n equal to 2 raised to 2. So n is equal to 2. That is why you have 2 select inputs here. Okay. So suppose you have say 8 by 1 mux. If you have an 8 by 1 mux, then 8 is the number of inputs. 8 by 1 mux means 8 inputs, 1 output. So 8 can be represented as 2 raised to n. This is 2 raised to n by 1. So 2 raised to n is equal to 8, or that is equal to 2 raised to 3. Therefore n equal to 3. So you should have 3 select inputs. Similar way, 16 by 1 mux, here n will be 4 and 2 raised to n. Inputs will be 16. Likewise, you can construct any multiplexer. So this is the basic block diagram of a multiplexer. So we need to construct a 4 by 1 mux using logic gates. Okay. So just to explain as to what is happening in a mux, let's assume that these are your inputs. So these are your switches. Okay, in a lab, in a digital trainer kit, you have 4 input switches, and Y is your output, so this is your LED. These two are also inputs, but these are used to select the inputs. So these are also switches. Physically, these are also switches. So what you will do is, these inputs will carry a particular value initially. Suppose I am just simply writing it as, suppose it is 1 0 0 0. Okay, so this switch is in the on position, this switch is in the off position. Now what I am going to do is, I am going to change the values of S1 and S0 and going to see what will Y be if my inputs are these. So what do I do? S1, S0, these are my select inputs, and I am going to check what is Y. So if I give S1 S0 0 0 0 0, so 0 0 means what? 0. So this is my 0 position, 0th input, I0. So I0 should be selected. The others, I1, I2, I3 should not be selected. Only I0 should be selected. And whatever is there in that particular switch, if it's a 1, then that 1. If it's a 0, then that 0. Whatever is there in I0, whichever position the switch is in, that value is transferred to Y. That is what is a multiplexer is. So 0 0 means I0 will be selected and Y will be, in this particular case, 1. Why? Because I0 is equal to 1. So actually what you are selecting is I0, and in this case, since I0 is 1, Y will be equal to 1. If I0 was 0, then Y would be 0 because I0 is 0. Now suppose I am giving this as 1 and I am giving the select inputs as 0 1. So 0 1 I am giving means I1 is selected. 0 1 is 1. I1 should be selected and that one should go to Y. That is, when you are giving 0 1, I1 should be selected. If it is 0, Y will be 0. If it is 1, then Y will be 1. Okay. Now, what if my input, select inputs is 1 0? 1 0 means 1 0 is 2. So I2 should be selected, and whatever is in I2, if it is 0, output will be 0. If it is 1, then output will be 1. So whatever value is there in I2, that will be selected and propagated to the output. And 1 1 means I3 will be selected and that will be available at Y. So this I0, I1, I2, I3, these can take any value 0 or 1. Depends on which position my switch is in. So what the mux does is, depending on the value in S1 and S0, one of these inputs is selected, input lines is selected, and the value in that input line is transferred to Y. Now I need to write an expression for this. Okay. So always after writing the truth table, this is your truth table, you will be writing the expression for output. Here my output is Y. So how will you write the output expression? So how do we read this? When S1 is 0 and S0 is 0, my output is I0. So when S1 is 0 and S0 is 0, whatever is there in I0 will come to Y. Suppose I am giving S1 as 0. 0 means 0 complement 1. S0 is 0. 0 complement is 1. I0 I am giving as 1, then 1. So Y is 1. If I0 is given as 0, then Y is 0. So if S1 is 0 and S0 is 0, whatever is in I0 that will come to Y. Or if S1 is 0 and S0 is 1, then whatever is there in I1 will come to Y. Or if S1 is 1 and S0 is 0, then whatever is in I2 will come to Y. Or if S1 is 1 and S0 is 1, then whatever is in I3 will come to Y. So this is my Boolean expression or logic expression. So now I'll have to draw this, a 4 by 1 marks. So this is my S1. I need S1 bar, S0, S0 bar, right? So S1 bar, S0 bar, I0. S1 bar, S0 bar. Here you can see that in the first expression you have 1 I0, second expression I1, third term I2 and fourth term I3. So I0, I1, I2, I3, these are coming only once. So I am not going to draw lines for I0, I1, I2, I3 because they are appearing only once. So I am just writing it as I0 here. So S1 bar, S0 bar, I0. Then next is S1 bar, S0, S1 bar, S0, I1, S1 S0 bar, S1 S0 bar, I2, last one is S1 S0 I3. So or all these. So for that, since you don't have a 2 input, 3 input or 4 input OR gate, you can use a 2 input OR gate. And another 2 input OR gate here and another OR gate here. So this is the first term plus second term here. This is third term plus fourth term here. So first term, second term plus third term plus fourth term, you'll get your Y here. You can do it like this, or if you want to do it using a NAND gate, then you can put NAND everywhere. final NAND. So this is a multiplexer. You can do it anyways. Likewise, you can do 8 by 1 mux, you can do 16 by 1 mux, any mux. So what we did was implement a 4 by 1 mux using first logic gates and second using NAND only. NAND only means you'll have to convert this also to NAND if you are going to do it using NAND only. Okay, so that is a multiplexer. Now there are many questions using multiplexer that is possible. In fact, many twisted questions can be asked using a multiplexer.